In this video, I will be showing you how to graph a sine function. First thing we would do is find the amplitude, period, phase shift, and its midline. The amplitude is essentially how high from its midline that the sine function is oscillating to a maximum and a minimum. So the amplitude is defined by y equals a plus or minus the sine of bx plus c plus d. So this a value is where we would find our amplitude. In this case, it's the absolute value of 3, which is 3. So that's its maximum and minimum value from its midline, which we will find shortly here. Next, we'll find the period of the function. The period is essentially how long it completes one complete cycle, or how long it takes to complete one cycle. In this case, we can use 2 pi divided by b, or the equivalent 360 degrees divided by b. I prefer to use 360 degrees divided by b because it makes it a lot easier to graph the function using degrees. So I will use 360 divided by b. b is the value or the coefficient of the x term. So we'll divide that by 2, and 360 divided by 2 is 180 degrees. So it will take 180 degrees to complete one complete cycle. Next, we will find its phase shift. The phase shift is defined to be the opposite of c divided by b. This is essentially a horizontal shift of the sine function. So let's take the opposite of c, which is pi. Pi is equivalent to 180 degrees. So I will use 180 degrees, or its opposite, divided by 2. So the phase shift for this function will be negative 90 degrees. So 90 degrees to the left. The midline of the function is the value or the line where y equals d. So in this case, it would be y equals negative 2. Using these values, which I will highlight, its amplitude, the period, how long it completes a cycle, the phase shift, and its midline will aid us in graphing this sine function. Now, to find a complete cycle from beginning to end, there are 2 ways we can do this. One, we can use the ax plus b, or I apologize, it's bx plus c. And given one complete cycle of the sine function is from 0 to 2 pi or 360 degrees. So if we use this compound inequality, we can find the start and the end of this cycle. Or we can use the phase shift, which is negative 90 degrees. And from negative 90 degrees, we can add the period of the function, which is 180. And the start and finish, or one complete cycle, will start at negative 90 degrees and end at 90. I find this one easier than to solve for the compound inequality, but I will show you how to use this method as well. So here we'll use the compound inequality, 2x plus pi. Again, we can convert this back to degrees. So if we want to make this 180 degrees, pi equivalent, and 2 pi equivalent is 360. So let's use that to be consistent. So what I'm going to do is now subtract 180 on both sides of the inequality. So 2x is less than or equal to 180, and 2x is greater than or equal to negative 90. Divide everything by 2. And again, we can see our interval goes from negative 90 to 90 degrees. So we essentially get the same interval. Now, we'll take the domain and divide it into 4 equal parts. Again, this will all start to make sense when you see the actual graph. Take the period of the function, which is 180 degrees, and we're going to divide it into 4 equal intervals, because the sine function will have 4 equal parts in which we will graph the domain. So 180 divided by 4, it's 45 degrees. So every 45 degrees, there will be a new interval. It will start at its phase shift, the horizontal translation of that, add 45, so it's just a simple calculation. So the next interval or value will be at negative 45, and let's just keep adding 45 all the way down. The next value will be at 0, 45, and last we should end at 90, just like the cycle indicates. So now to graph this, what I'd like to do is just now draw a generic graph. We're going to start at negative 90 degrees for our phase shift. Then we're going to go to negative 45 degrees, 0. So again, kind of make them as equally spaced as you can. Then we'll go to positive 45, and then 90. One thing we have to keep in mind is we need to graph the midline. Which is at y equals negative 2. So I will graph my midline at y equals negative 2. What we do know about the function, it has an amplitude. So from this midline, the amplitude is 3. So it will have a maximum value of 3 and a minimum value of 3. So I need to extend this down one more. And up. What we know about the sine function is that it starts at its intercept, or 0. So it's going to start at negative 90, the phase shift. It's going to go to its maximum amplitude of 3. So from the midline, we will go up 3, 1, 2, 3. So that will be its maximum. Then it comes back down to its midline, the 0 or the intercept. Then it will go to its minimum amplitude at 45 degrees, and then it will come back up to its midline again. So your sine function would run through one complete cycle. Again, we can continue this cycle in either at the positive or negative direction just by adding 45 or subtracting 45 to the left of its phase shift. I hope you found this helpful in graphing a transformation of a sine function.